So as I told you in the previous video that when you take the derivative of a function, the answer you get is the gradient equation of that function. So what do I mean by that? Let me clear it up. Let's say this is our f of x equals to 4x squared plus 5x plus 4, and this is its graph. Right? It's a parabolic graph. Now if I take the gradient of this function f of x, I'll have to write f complement of x. This will give me 8x plus 5. So basically this is the gradient equation of this graph. Now if I were to draw the graph of this derivative, it will be somewhat like this. It will cut the x-axis at 5 and have a positive gradient like this. Right? So this is the graph of f of complement of x, 8x plus 5. Right? Now if I were to find f of 1, f complement of 1, this will give me 8 plus 5, which is 13. So basically what this means is that the gradient of this curve at x equals to 1 is 13. The gradient of this curve right here at x equal to 1, let's say this is 1, at this point is 13. I hope you understand what I mean by that the derivative of a function gives you the gradient equation of that function. This is the gradient equation of f of x. So if you put 2 in this in the place of x, you'll get the gradient of this curve at x equal to 2. If you put 3 in this, you'll get the gradient of this curve at x equal to 3. Same goes for x equal to 5, 6, 7, 8, 9, 10. Alright, so even if you put x equal to negative 1 in this, you'll get the gradient of this curve at negative 1, which will be somewhat right here. Alright, gradient of the tangent of this curve at negative 1, you'll get that if you put negative 1 in its first derivative. Alright, this is the first derivative. Now how do we actually take the derivative? You have to learn this rule that the concept behind taking derivative is this: f complement of x equals to limiting change in x to 0 as x approaches to 0, f of x naught plus delta x negative f of x naught over delta x. So this is how you actually take the derivative. Now you won't be using this formula at all in your syllabus. Alright, you won't use this at all. So what you learn basic rules that if we have a function, let's say x cube, what will be its derivative? The derivative of x cube will be, you bring the power down and reduce the power by 1. So derivative of x cube is f complement of x is 3x squared. Right? So you'll have to learn this rule that whenever you have the x of n, you take derivative d by dx. It means taking the derivative with respect to x. Right? This term means taking the derivative with respect to x. If you apply this on x of n, you'll get n x n minus 1. Right? So all you have to learn is this, that d by dx, this is the term for the derivative, this is the symbol for the derivative term. If you take the derivative of x of n, the output will be n into x n negative 1. Right? So d by dx is basically this thing, this f complement right here. Right? You can write it as d by dx of or f complement or y complement, because y equals to x cube of x, right? So y of complement will be the first, this means the single derivative, 3x square. If this is y double complement, this means the double derivative, that will be 6x, right? So all you need to learn is this: when x has a power n, the derivative is you bring the power down and reduce the power by 1. Now what if you had to find the derivative of a constant value? Let's say d by dx, you're supposed to find the derivative of d by dx of 4, right? So we know that if y equals to 4, if this is our line y equals to 4 right here, So the gradient of this line is what? 0, right? So the whole concept of differentiation of derivative revolves around the gradient. So the gradient of a constant number will also be 0, because what derivative gives you is the gradient equation of that formula, or gradient equation of that function. Now the gradient equation of 4, we know that the gradient of 4 at all points will be 0. So the derivative of a constant term is 0. Now you need to learn this one. D by dx of k of a constant number is 0, right? And third thing is, this is the first thing you need to learn. This is the second thing. And the third thing is, d by dx is a function, and it is associative. For example, if I were to find the, let's say, if I had y equals to x cube plus x square plus x 3x, and if I were to find the rate of change of y with respect to x, or if I were to find d by dx of y, so this will give me, I'll apply d by dx on x cube plus d by dx on x square plus d by dx on 3x, right? So this will give me 3x cube, 3x square, bring the power down, reduce the power by 1, plus 2x, bring the power down, reduce the power by 1, plus 3, that's it, 3 into 1. Because when you bring the power down, which is 1 in this case, and multiply it by the 3, you get 3, and when you reduce this power by 1, you get x raised to the power 0, and x raised to the power 0 is 1. So your answer is 3x square plus 2x plus 3. So this is your answer. Now fourth thing you need to learn is how to take the double derivative and how to actually write it. For example, if they ask us to take the double derivative of y, and y is given to us y equals to 3x power 8 plus 4x cube. Now when I apply d by dx for the first time, this is the single derivative. This will give me 3 times 8 x 8 minus 1 plus 4 times 3 x 3 minus 1. So basically what happened here is this. When I apply d by dx on y, I want to tell you here something. So we apply the derivative on x, on the function, not on this number, on the function itself. So plus 4 d by dx into x cube, right? So then we get this answer. So this will give us 24 x raised to the power 7 plus 12 x square. This is our single derivative, d by dx of y. Now they have asked us to find double derivative. So what we'll do is we'll apply d by dx on this expression again. So I'll apply d by dx on d by dx of y. So I'll get 24 times 7 into x7 negative 1 plus 12 x into 2 into x2 negative 1. This will give me 7 4 the 28, 7 2 the 14, 168 x power 6 plus 24x. So I'll write this as d squared of y over dx squared, right? Or this could have been written as f complement of x equals to 24 x7 plus 12x square, and this could have been written as f double complement of x 168 x6 plus 24x, or you could have written y double complement here or y single complement here. So what I'm trying to say is you need to familiarize yourself with these terms. Y single complement equals to f complement of x, equals to derivative applied for a single time, right? d by dx of y. Y double complement equals to f double complement of x, or derivative applied twice, d square over dx square of y, right? Get it?